Hello guys, so today we are here to solve this legendary problem, find minimum in rotated sorted array. So this problem is very famous and you know there is every chance that this problem can be asked in any interview. So let's try to solve this problem. So in this problem we are given an array. So input to our problem is this int array. So obviously it is an integer array of ints, and in this the elements are first sorted, and after having the elements sorted it is rotated between 1 and n times. So you see this thing is a sorted array, and if it is rotated 4 times, so it means that 4 goes to the front like this, and 0 1 2 comes at the back. Okay, so it is sorted and rotated, and we have to figure out the minimum element of this array. So how can we do this problem? Okay, so to do this problem we have to, you know, we have to understand some things about this problem, that so suppose, if something is sorted, then it will be, uh, so if something is sorted, so it will be like this. I mean to say, you are getting my point. So if something is sorted, the lowest element will be at the 0th index, and the highest element will be at the last index. And the magnitude of the elements will be, going like this. But it is not just sorted, okay? It is sorted as well as rotated. So then how it will be? So in this case, it will grow, but at a certain point in time, there will be a dip, and then again it will be growing. Okay, so earlier when the array was, not rotated, it was just sorted, then it was, just growing. Okay, it was just growing like this. But now it is sorted and rotated. So in this case, it will be like growing like this, and then there will be a sudden dip, and this sudden dip, and again there will be, the elements will again be growing. So this zigzag things is coming in, in the middle of the array. So suppose, you know we are at this index. So we see, the previous element is smaller and the next element is larger. So it means that, here this dip is not there. Then this dip is not even in this left half. It will be there in the right half. Why? Because see, this mid is, if you check with the extremes, left extreme, this mid is greater than that left extreme, but this mid is smaller than this. Ideally, the mid should be greater than the left, and it should be less than the right value. But since it is rotated, sorted and rotated, that's why this thing at the end is, is smaller than this mid value, and this is the clue which is telling us that this sudden, drop in the value is happening in this half. I'll explain this as and when we do this problem. So let's, start doing this problem, and it will be clear to us. So okay, so first of all we need to declare some values. int low is equal to 0, high is equal to nums dot length minus 1, mid is equal to -1, and then yeah, for now let's declare only these much values. And one more thing, now this, if nums of low is less than equal to nums of high, so this will be returning, this will return nums of low. Why? So see, this condition is telling that if the array is not at all shorted, it's not at all rotated, then in that case the smallest element in the array will be at the lowest position. If that is at the lowest position, then we have to return that nums of low value. Okay, so it is less than and equal to. So nums of low is less than and equal to. And why we are doing this equal to? See, all the elements in this array is distinct. Here it is mentioned, all the integers of this array are unique. Then why are we using this equal to? There could be a possibility that the array is having only one element. So for to check that, we have put this nums low is coming the same as nums high. So in that case, we'll be returning, we could have written nums high as well, but the condition when the array is not at all rotated, for that also to work, we have returned nums low. So nums low will, this line will take care when the array length is only one, array length is only one, or the not at all rotated. So array is not at all rotated. So this one condition is taking care of these two things. Okay, and then what I want to do here is I want to use, see, the condition that is given over here, that you must write an algorithm that runs in big O of log n time. This is just a giveaway that we have to apply binary search. And to apply binary search, what do we need to do? While low is less than equal to high. So what is the meaning of low is less than equal to high? So while low is less than and equal to high, we are will be within the loop. As soon as low crosses the high value, the low value crosses the high value, we will terminate the loop. Okay, and now the mid is going to have this low plus high. So this is doing this, and then we are finding it. And now what we have to do here, so remember, after finding the mid, we have to check if mid is greater than 0 and nums of mid minus 1 is greater than nums of mid. So what does this thing is telling? Mid is greater than 0, so mid minus 1, we cannot have array index out of bound exception for this mid minus 1, because mid is greater than 0. So mid is greater than 0 means the lowest value that mid is going to have is 1, and 1 minus 1 is 0. So this is not going to have array index out of array index out of bound exception is not going to happen in this. And now this nums is mid minus 1, and then it is greater than nums of mid. So in this case, what is this going to tell us? Okay, so mid is greater than 0, nums of mid minus 1 and greater than nums of mid. So this is telling that this sudden decrease that is happening. See, mid minus 1 is the lower index value and mid is the greater index value. So if it is not rotated, then the values would be, incrementing in magnitude. They'll be gradually, increasing in magnitude from lower index to higher index value. But here what is happening, that mid minus 1 is greater than the next value. So it means here the decrement, sudden drop in value is happening at this point, and we have to return this nums of mid, because this is the min value, because it is happening at only one place and this is the place. Or else mid plus 1 is less than equal to, so we have to have, end index is equal to, let's say, high. So less than equal to end index, and nums of mid is less than, nums of mid is greater than nums of mid return nums of mid. Okay, else if nums of low is less than nums of mid. So in this case, the point of inflection is happening at low is equal to mid plus 1, else high is equal to mid minus 1, like this, return minus 1. Okay, so we'll run this. We are getting a wrong answer. Expected value is, so mid is greater than 0, mid minus 1 is greater than nums mid, mid plus 1 is less than equal to end index, nums mid is greater than mid plus 1 returns nums mid plus 1. Okay, now we'll run this. Perfect. Perfect. So this is one way to solve this problem. Now I want to tell you one more thing. See, here we are comparing with nums of low. What if we compare it with the nums of high? So to do that, we can do that. So do you think if I just make it like the nums of high is less than nums of mid, then yeah, so this is also this also should work. Perfect. Perfect. So this is one solution to solve this problem. If you have any doubt, please, post it in the comments and I'll definitely try to answer, those doubts. With this, I would like to, end this video. Happy coding. Best wishes to all of you. Stop stopping yourself.